Good morning, students. I am Sherin Beevi, Assistant Professor in CSE Department in RMD Engineering College. Today we discussed about the topic is interfacing multiple 7-segment displays. The physical view of 7-segment displays are A, B, C, D, E, F, G. So totally 7 segments. One more segments are there that is called a data pointer that is always disable only. So mostly we are using these 7 segments only. So here I am going to explain the program to display the word attitude in common cathode 7 segment LED display. So here A, it is looking like that how it will be displayed in the LED 7 segment display. The segments A, B, C, D, E, G will be turned on and the segment F will be turned off. Then it is looking like a character A. At the same time, D, E, G, F will be turned on. A, B, C segments are turned off. Then it will be looking like a character T. The same way to display the word attitude in 8 different LED 7 segments display. Here it is a hexadecimal number which are equivalent to the word attitude. So here A means all the segments will be turned on except the segment F. So here A to H. So it is a 8 segments display. Mostly we are using 7 segments. The additional display it is called the data pointer. It always disable in all the words. Yes, the physical view is only 7 segments. So here except F, all the segments will be in turned on. So put 1 in for A, B, C, D, E except F and the data pointer is H. Okay, so here we can able to add these values. So converted to the binary number. So 1 plus 2 plus 4 plus 16 and 32 and 64. So we are getting the answer is 95. So 95 is a decimal number equivalent to the character A, but we need a hexadecimal number. So 95 take a LCM by 16. So we are getting the answer is 5F. That is a hexadecimal number. The similar way we can able to calculate the hexadecimal value of T I T U D E. So 8 segments hexadecimal equivalent values of attitude we initially find out. Okay, so this is interfacing diagram of multiple 7 segment display. So interfacing, it is the one of the example of interfacing is 8255. It is a parallel communication interface. It will be connected between some peripheral devices to the 8086 or any other microprocessor. So peripheral devices or external devices, it is very difficult to communicate to the processor. So interface it is can be used acting as a middleware to communicate between external or peripheral devices to the processor. So here multiple 7 segment display it is called a peripheral devices and 8086 acting as a processor. A255 parallel programmable interface having three different set of ports. So port A acting as a digital driver, port B acting as a segment driver. Okay, so port B directly connected to 8 multiple 7 segment display. Why we are connecting to the 8 means the character of a attitude is 8 letters. So 8 LEDs connected directly to the port B and each and every LED is connected to one transistor. The name of the transistor is Q1 to Q8. The each and every transistor, the base point is E1 to E8 connected directly to the port A. It is acting as a digit driver. It is common cathode method. So the E8 value changed to 0, then to pass the input value through the port B, then the output will be displayed on the corresponding LEDs. So see, this is the example program to display the word attitude. We initially assign the address value of control register port A and port B. So to initially to assign some address values. So here table. So the attitude A equivalent hexadecimal value is 5F and T equivalent hexadecimal value is 78. H represents the hexadecimal value. So the equivalent words of attitude 8 hexadecimal value saved inside the table. The name of the table is DB. Okay, so table is nothing. It is like a lookup table to holding the values equivalent to the word attitude. It is acting as an array. So here initially 80 Hz should be assigned saved inside the accumulator AL register, 8-bit register. 8 means equivalent binary number is like this, and here the first value acting as a in IO mode operation. This is used for IO mode operation. This is for port A and this is for port B. And then again to copy this accumulator value to the register CR. CR it is a control registers. The initial address of the control register is 0C6. Okay, to start the program. So here initially the source index values to display the data. Okay, the table is looking like a array format. It will be saved inside the source index register. 8 is the count. CX acting as a count register. Why the value of count is 8 mean totally 8 character inside the word attitude. So that's why count is 8. So it is a bit sequence of the leftmost digit. The value is 0 initially. That means see this diagram. E8 value is 0 means turned on the transistor. Then the 55F Hz, the initial, the first value moved through the port B. Then the A will be displayed in the eighth 7 segment display. Okay, so that's why this value assigned to the BL register. Again, the BL register copy to the accumulator. The accumulator value again move to the port A. So based on this input, now this E8 value should be changed to the zeroth mode. Enable. Remaining all the LEDs are disabled because all the remaining values are one only. Okay, at the same time, the values within the square bracket mean the address of the value. So SI is having some address, we can able to take the value inside the address. That means the value is 5F, that is moved to the accumulator. Again, the accumulator value moved to the port B. So port B, the accumulator value is now 5F, and already the values E8 value is 0. So that's why A will be displayed in the first LED. So call delay. So delay means it can be used for to display the corresponding characters on the 7 segment display. Okay, the base terminals of all the transistors corresponding to the port A. So E1 is connected to the Q1 transistor, E2 is connected to the Q2 transistor. Likewise, E8 is connected to the Q8 transistor. The 0 means turn on Q8, then display the A on the 8th position. So turn on the transistor Q7, then pass the value 5F through the port B to the Q7. Then A will be displayed on the first this LEDs leftmost bit. Okay, the delay means for sometimes the A will be displayed then it will be moved to the another character. So here one character will be displayed to move the to change to display the another character. In between time it is called a delay. Okay, so after the display the character A, then delay, then increment the value of the SI. So increment means the SI value change to the 78. Then ROR means rotate right order. Then BL value is this one, it will be rotated. So initial value is this means, so this value changed to the second position. So 0 change to the second position, the one third position again. Okay, so here the first value 0 changed to the second position mean the rotation it is based on the value 1. So 1 is moved to the first. Okay, so now the new value of BL is this one after the rotation. So the here this the second position should be 0. The second position mean E7 value change to the 0. Okay, E7 change to the 0 means the next values already SI is incremented. So 78 value moved through the port B to here. Already E7 is stand on 0. That means E7 changed from 1 to 0. So the T will be displayed. So initially A is display, then again T will be displayed. So after that in between A, the character A is display, then T is display. In the in between time it is called a delay. Again again delay, then again incremented by SI. Here change to the character value is 878 hertz. Again rotation, the 0 move to the third position. Third position mean E6 value changed from 1 to 0, that is enable mode. Then at the same time 78 hertz passed through the port B, and the again T will be displayed in the third 7 segment display. So likewise A T T I T U D E to be displayed. So that is a totally 8 values, 8 character display. The count value is 8. Okay, so here the same procedure is repeat until the CX value change to 0. Once the CX value change to 0 means altitude will be displayed only one times. The remaining program it is called a delay program. To assign the delay value is 300 to the register DX value. It is decremented by one. So when it will be stopped means jump not equal to 0. Okay, so here again it will be repeat when it the delay value should be changed to 0, then to end the program. Clear? So some this is one of the important questions. So mostly asking these questions for different letters. For example, to display the word is hello means totally 5 character. Okay, so some small changes inside the program. So here first to be find out the equivalent hexadecimal value of the character HELLO. Okay, that will be saved like array format inside the table, and the count registers values also 5. The remaining procedure is same, but here also only 5 digits. Sometimes ask the question is 2021. So that means equivalent hexadecimal value of 2021 to be find out, and that value should be saved inside the table. And here also hello need to be display means only 5 LEDs connected to the port B, and 5 transistor, and the each and every transistor base is directly connected to the port U. Some small changes inside the diagram and the program. The remaining concept and the logical wise is same. Thank you, students.